Hello, everybody. Right off the bat, I've got to confess I'm as excited to do this lesson as perhaps any other lesson of the year. And our title tonight is Can You Afford That House? And basically, the reason I'm so excited is I think we're going to take everything we've been doing for the past several weeks and combine it all together and apply it to some real life scenarios. And it's going to get as real as it ever has. We're going to hopefully give you a chance to pick out a house that catches your eye and tailor it to your own anticipated career and see if you've got if you can afford that particular house or not. And we're going to see everything we do inside the classroom translate in a real way to the real life here. So the first thing we need to do, and I think might as well go ahead and get this out of the way because this is going to be the number one thing I need you to come into class tomorrow with, is first I need you to just select a potential career that you're interested in, okay? And then we're going to Google that and try to figure out what the starting salary is for that particular career. Again, we're not locking you into this career, so just search around a little bit, find one that you're interested in, and try to find the starting salary. And number two, I want you to go house searching tonight on the internet and try to pick out a house that you'd like to purchase and jot down the price of it. And I think just to make it a little more real, if you've got a chance, if you can print out a picture of that house and just tape it inside your notebook, that would be outstanding. And I think it would make it a little bit more fun as we try to solve this problem tomorrow in class. So what I've done is I went ahead and I went with a career in computer engineering. And the starting salaries looked to be about $65,000. That was a little on the conservative side. I figured I'd, kind of lowball it a little bit. And then I started kind of Googling, and I think I ended up on Zillow. And I found a house that really caught my eye, looked really nice, and this one was $230,000. So what we're going to do is we're going to try to model what you guys are going to do tomorrow with your career and your house. And we're going to try to figure out if I can afford this house on a $65,000 starting salary. And, hopefully I can. Otherwise, it might be a rude awakening, and I may have to go looking for a different house. So I think here we're going to introduce you to a lot of different terms and such. Maybe you've heard these terms during a commercial while watching TV, or maybe you heard your parents talking about these different terms and stuff. But hopefully we're going to give, with these definitions, we're going to give them some meaning. And this is going to be maybe the most overwhelming page of our notes. But I think with a little bit of practice, we'll get the hang of these. So right off the bat, these are the rules that we're going to play by, okay? For instance, mortgages are loans that are usually offered in 30, 20, or 15-year repayment options. We are going to start with a 30-year mortgage, okay? So what I do tonight in the video and what you guys do tomorrow in class is we're going to use a 30-year mortgage. Now, just again, a mortgage, it's a loan. It's the amount of money that we're going to borrow from the bank and then pay it back over a 30-year time span. Now, the annual interest rate for your mortgage will be 5%. Okay. Number three, your payment includes the payment of a loan for the house, okay, as well as payments on an account called an escrow account. And here's where it gets a little goofy. Now, your escrow account is used to pay for your taxes on your house as well as your insurance on the house, okay? So we're not going to get into too much of that. Basically, we're just going to kind of approximate our annual payment to the escrow account as 1.2% of the home selling price. So, but it's just important to know that each month, we have a payment going to the bank, and we also have a payment going into escrow to take into account the taxes and the insurance on our house. Again, this is very real. I remember it wasn't too long ago when I was trying to learn and sort through these terms myself for the first time. Number four, the bank will only approve a mortgage if the total monthly payment for your house, including the payment to the escrow account, does not exceed 30% of your monthly salary. Okay? See, basically, the bank wants to make sure that you're going to pay them back on this money that they're lending you. And so in order to determine whether you get approved or qualify for this loan, they're going to look at your monthly salary and make sure that the payment for your house doesn't exceed 30% of that. And number five, and this is the assumption we're going to make, is you've saved up enough money to put a 10% down payment on the house. Okay, so what I want to do now is I want to take a look at the scenario that I proposed with my anticipated career as a computer engineer. And my annual salary was going to be $65,000. So the first question is I want to figure out what's my monthly salary. So what I did is I divided my $65,000 by 12, and that turned out to be about $5,416.67. Now, ironically, especially if you stay in New York, you'll never actually see $5,416, and you can talk to your parents about this one. Uncle Sam's going to get his hands on a lot of that money, and you'll actually see considerably less than this. But we want this to be kind of a feel-good story, so we're gonna pretend you live in a state with very low taxes. And then, what's 30% of your monthly salary? Well, what we're going to do is we're going to multiply 0.30 by the $5,416.67. And that turned out to be $1,625. So, and this is the number that the bank's going to look at here in just a moment. Okay, next question. Now remember, the house that I had picked out cost me $230,000. So how much will you pay in escrow? Now we defined escrow as about 1.2%. So I'm going to move the decimal place twice and multiply that by my $230,000 house. And so for the year, I would pay $2,760 to cover all my taxes and insurance. And how much would that be per month? So if I divide that bear by 12, that's going to turn out to be about $230 per month that is going to be devoted towards taxes and insurance. So we're going to stick that number in our back pocket. Okay, next, how much is our down payment? Now the down payment, and this is very traditional, very universal, about 10%. So again, moving the decimal place twice, multiply that by the price of your house. Okay, and we should get $23,000. So that's how much, and again, we're assuming that you have this much saved up to put as your down payment already. So we're going to put a down payment of $23,000, which means if I subtract that from the original price of the house minus the down payment, that means I've got to borrow from the bank $207,000. So that's what my mortgage is going to be for $207,000, not $230, because of the down payment that I've already paid. Now, as far as mathematically, and what we need to know for our course and going forward into our next exam and so forth is, here's a crazy formula that we're going to introduce you to right here. And basically, as it says, this is how monthly mortgage payments can be found, where M represents your monthly payment, okay? P is the amount borrowed from the bank after you made your down payment. R is your annual interest rate, and N is the number of monthly payments. So sometimes we may have to convert years to months and so forth. Now again, similar to like our Newton's law of cooling, this is not a formula we have to memorize or anything, but it is a formula that we want to practice manipulating and just getting experience with it so we know where to plug in certain numbers and how to solve. Now as far as tonight goes, sometimes we're just going to be solving for M, which is going to be the friendliest. Then there's going to be other times where we have to solve for P, which gets a little bit harder. And then ultimately we're going to try to solve for N, which gets the hardest. And when we solve for N, we're going to eventually use logs because that N's in the exponent. So here's where the number crunching is going to start to get heavy. And the question is, will the bank approve our loan? So here's what the bank's going to sit down and do is they're going to figure out, let's see, in this particular case, after my down payment, I wanted to borrow $207,000, right? And we said earlier in the video that we're going to assume that our interest rate's 5%, which actually, right now, it's a little bit lower. But anyway, plus 1.05 divided by 12. Here's a little bear trap. The N's the number of months, but it's a 30-year mortgage. So if I multiply 30 times 12, that would be a total of 360 months. And then on the bottom, again, it's 1 plus 0.05 divided by 12 raised to the 360th power minus 1. And the good news is I'm just going to type that all into my calculator at once. And that gave me $1,111.22. That would be my monthly payment to the bank. Now remember, that's just my payment to the bank. I'm going to now add to that the $230 monthly payment that I'm going to owe for escrow. So each month I'm going to have to pay $1,341.22 to pay for my house. So the question is, can I afford this a house? Will the bank approve it for me? And the answer is yes, because 1,341 is less than the. Sorry about that. Bailey's getting a little excited here. It's less than $1,625. That was, and remember this number was from earlier. That was the 30% of our monthly income, our monthly salary. So because this number is smaller, we're going to get approved for this particular house. So the first thing we're going to do in class tomorrow is you're going to walk in with a career that you're potentially interested in. You're going to have data to support what the starting salary is for that job. And then you're also going to have picked out a house with its listing price. Okay, and like we said, I think if you have the ability to print off a picture of that house and tape it in your notebook, I think that'd make it even more exciting. And so what we're really expecting is that everybody's going to walk in with unique numbers. And the first half of class tomorrow is we're going to walk through the same process that I just did. And we're going to try to determine if you can afford that house with your starting salary. And it's okay. It's not, it doesn't have to be a yes. It's just going to be kind of an experimental process. But I guess what I want to challenge you to do is, be unique. And we'd be really surprised if you had the same numbers as a friend of yours. But anyway, we'll get a little more practice with this formula here. And it says, last spring, the average listing price of a home in Greenville, South Carolina was $180,000. Suppose you want to buy a house for this price with a 30-year mortgage at a 5.5% annual interest rate, paying 10% down with an annual escrow payment that's 1.2% of the full price of the home. What is your monthly payment going to be on the house? Okay, now the first thing we've got to decide is how much we're going to borrow from the bank, because remember, I'm not going to borrow $180,000. I'm going to do a 10% down payment. So first things first, if I take $180,000 and I multiply it by 10%, that's going to turn out to be $18,000. So if I subtract the $18,000 from the $180,000, my principal here, how much I'm going to borrow, is going to be $162,000. That's how much I'm going to borrow from the bank. Okay, so let's see if we can plug it into that crazy formula we saw earlier. So this isn't going to be too bad. We're going to start plugging and chugging. Let's see. So we have $162,000 that we want to borrow from the bank. Let's see, 5.5% interest, slightly different than the last example. And I'm just going to be very, very careful about plugging everything in. Let's see. And again, this will be raised to the 360th power because it was a 30-year mortgage. And then once I get everything plugged in, it's just going to be a matter of grabbing the calculator. And I do try to type the whole thing in at once. And I do go to Alpha F1 and grab my fraction thing and type it all in at once. So let's see what the monthly payment turns out to be here. So my monthly payment to the bank is going to turn out to be about $919.82. Now that's not the only thing I have to worry about, though. I also want to consider my escrow. Now, it was a $180,000 house, and we're going to pay about 1.2% per year to escrow. And so on a yearly basis, it's going to be about $2,160. But if I divide that by 12 to get my monthly cost, it's going to be about $180, whoops, 180, for my escrow account. So what is my total monthly cost? Well, let's see. We got $919.82 going to the bank, plus $180 going towards taxes and insurance, for a grand total of $1,099.82 for this house in South Carolina. Okay, now we're going to cover the saddest, most depressing part of this, but this is very real. So the question is, how much was paid total to the bank over the life of the loan? Now remember, we're just focusing on the bank here. This time we're not going to worry about escrow. Now here's the trick. You were paying $919.82 to the bank every month. Now how long do I have to do that? Well, I got to do that for 30 years, which is a grand total of 360 months. So over the life of the loan, I'm going to have to pay the bank $331,135 $1,000,000.20. Okay, so that's, now remember, the house was only cost $180,000. So now the question is, how much did you pay in interest? Well, I'm going to take the 331, 135, and I'm going to subtract the list price of 180,000. Okay, and so just in interest alone, I've paid $151,000, 135.20. So that's how much I just paid in interest on top of the list price. So that one stings a little bit, but that's the real deal. So, and if we had more time, what we do is say, okay, well, what if you could get your mortgage down from 30 years to 20 years, or from 20 to 15 years? And that's where you're going to really see this price right here start to drop, and it would be a huge advantage to us as the buyers. So things are going to start to get a little hairier here. They said, suppose you can afford a monthly payment of $700. What's the most expensive house you could afford, assuming the down payment was already made? And I'm just making that assumption, so it's our calculation. Basically, we're saying we're just going to solve for P. With a 30-year mortgage and a 4% annual interest rate. So like I said, we know that our M wants to be 700, we know what our R is, we know what our N is, and we just want to solve for P. And I think this is a useful exercise, so before you even start going house shopping, and wasting your time maybe looking at houses that are a little outside of your budget, let's just figure out what our maximum cost is right off the beginning. So let's say 700 is equal to P, and then we'll say 0.04 divided by 12, and 1 plus 0.04 divided by 12 to the n. And now as far as solving for P goes, this is going to get a little hairy mathematically, so I want you to hang with me. Whoops, I should have just put in my 360. There we go, 360 there, minus 1. So what I want to do is, let's put the 700 over 1, and let's cross multiply, okay? So it's going to be 700 times this quantity right here, okay? Like I said, this one's going to get a little hairy. So I got 700 times 1 plus 0.04 divided by 12 raised to the 360th minus 1 equals, and then it's going to be P times 0.04 divided by 12, 1 plus 0.04 divided by 12 to the 360th. Now what you want to do, and because what you have here is multiplication, and the inverse of multiplication is division, what we're going to do is we're going to divide both sides by this 0.04 divided by 12 rascal, and the 1 plus 0.04. And like I said, we want to do that to both sides. And then I'm just going to type the whole thing into my calculator. And that's going to figure out what the most expensive house I can go start looking for is, assuming that I've already got enough money saved up for the down payment. And I tell you what, I know this sounds goofy, but don't take this for granted. I think you really want to take your time and see if you can plug this into your calculator. So even if you have the TI-84 and you've got the updated version, you're doing Alpha F1, you do need the double set of parentheses here. And then I'm thinking of Josh and everybody else that has the TI-83. You guys are really in a pickle. You're just going to have to use lots of parentheses. You probably use an extra set of parentheses around your numerator and an extra set around your denominator, and you should be able to type that all in. But when I'm all said and done, I got an answer of $146,622.87. So I would just confirm that your calculator is giving you the same number so that you're confident walking into class tomorrow, and we'll be ready to go. Well, of course, we saved the stickiest one for last, and this will be by far the hardest one we do. And what you're going to see is in this particular formula, they're going to give us M, they're going to give us P, they're going to give us R, but they're not going to give us N. So solving for N, as we alluded to at the beginning of the video, is going to be the most challenging thing, and it's going to require us to use logs towards the end of the problem. So here's how the story goes. The Mack family would like to borrow $140,000 to purchase a home. Now they've qualified for an annual interest rate of 4.5%. Algebraically determine the fewest number of whole years, or in this case we'll look for months first and then convert that to years, that the Mack family would need to include in the mortgage agreement in order to have a monthly payment of no more than $740. So they know how much the house is going to cost. They know how much they can afford per month. Now they got to figure out how many years should they agree to. Can they get away with a 15-year mortgage, or should they do a 20, or do they have to bump it all the way up to a 30? That's ultimately our question here. So let's see if we can get things cranking here. Let's see. We know that M is 740. We know that the principal is going to be 140,000. That's how much they want to borrow. We know that the rate is 0.045 divided by 12. And the real pickle here is going to be solving for N. So hopefully I can keep my handwriting neat enough here that you can read it throughout the process. Again, similar to the last problem, the first thing I'm going to do is I'm going to cross multiply. And as I cross multiply, what you're going to see me do is you're going to see me distribute the 740 to the first term, which is everything raised to the nth power, but you're also going to see me distribute it to the 1. Whereas in the last problem, I didn't distribute it. I just kept a big set of parentheses around it. But in this particular problem, it's going to be better if we distribute. So I've got 740 times this big blob. 0.045 divided by 12 to the nth power minus 740 equals, let's see, 140,000. 0.045 divided by 12. I'm going to run out of room. Oh my goodness. Let's see if we can squeeze it in here. And that is being raised to the nth power. The next move you're going to see me make is I'm just going to start to clean up some of the numbers. For instance, I'm just going to type in 1 plus 0.045 divided by 12 and see if this is any easier. So that turned out to be 1.00375 raised to the nth minus 740. The next thing you're going to see me do is I'm just going to multiply all of that together, and that gave me 525. And then again in the parentheses would be 1.00375 raised to the nth power. So it looks just a little cleaner. Now believe it or not, we do have some like terms here. It's hard to imagine, but there are some like terms. For instance, this term here is considered a like term with this term here because they have the same base raised to the same power of n. So what I'm going to do is I'm going to subtract 525 1.00375 to the nth power from both sides. It's very unusual. When we talk about this concept of like terms, we're not used to them necessarily being exponential terms. Okay, so as I get done subtracting those, 740 minus 525 gave me 215, and then of course the base stays the same, raised to the nth power. Now what I'm also going to do is I'm going to add, do you see this rascal right here, this 740? I'm going to add 740 to the other side. And now we're really cooking. I think you're going to feel really confident from here. We're solving for n, of course, so I'm going to divide both sides by 215. That'll cancel these rascals, and I get 1.00375 raised to the nth power equals 3.44186 ... and I can store that number. And here's the next fancy trick is I'm going to take the natural log of both sides, and that's going to move this n out front. So I've got n multiplied by the natural log of 1.00375 equals the natural log of 3.44186. And I do like to put parentheses around those guys. And then so last but not least, I'm just going to divide both sides by the natural log of 1.00375. So here's what that's going to tell me. I got, on my calculator, I got n equals about 330.2, whoops, forgot the zero, 330.22, yada, yada, yada. Now that's the total number of months that it would take me to make those payments. So if I divide that by 12, it's going to turn out to be about 27.5 years. So as far as like what type of mortgage I'm going to need, a 15 or a 20-year mortgage wouldn't do it. I'd have to, because of 27.5, I'd have to round up to a 30-year mortgage, unfortunately. But of course, if I was able to increase my monthly payments and make it a little bit higher than what I said it was, then maybe we'd have a better chance of getting it down to a 20-year mortgage.